Hello students, here is a question. A ball of mass 10 kilos is moving with a velocity of 10 root 3 meter per second along the x-axis, hits another ball with of mass 20 kg which is at rest. After this collision, the first ball comes to rest while the second ball disintegrates into two pieces. And one piece starts moving along the y-axis with a speed of 10 meter per second. The second piece starts moving at an angle of 30 degrees with respect to the x-axis. The velocity of the ball moving at 30 degrees with the x-axis is x meter per second. The configuration of the pieces after collision is shown in the figure below. The value of x to the nearest integer is. So here, if you look, we have this case. There we have the first ball which is moving at 10 root 3 speed over here. We have a second ball over here at rest. When they both hit, the second ball disintegrates into two pieces, where the first piece moves in the y direction and the second piece moves in an arbitrary angle of 30 degrees to the x-axis. So over here you can see there is no loss of energy, and by my saying that there is no loss of energy, we can say that the momentum is conserved. So before collision, the initial momentum becomes 10 into 10 root 3 for the first ball plus 20 into 0 for the second ball, and the total becomes 100 root 3. And after collision, you can see that in the x direction, because there are two balls of 10 kilos mass each, so the first ball, or the first over here in the x direction, because the y direction ball won't have any component in the x direction, so the x direction or the arbitrary angle ball will give a x component having velocity of v2 cos theta, and the momentum becomes 10 into v2 cos theta. In the y direction, the momentum is 10 into 10 for this ball, and the y component of this ball, that is at an arbitrary angle, which is 10 v2 sine theta, which becomes 100 minus 5 v2. So here this is the momentum in the y direction, this is the momentum in the x direction. We need to find v2. So what we said is we are going to apply momentum conservation because no loss of energy has occurred, and thus initial momentum, which is in the x direction, 100 root 3 I, that is in the x direction, becomes 100 or 10 root 3 by 2, which is 10 cos 30 into v2. Cos 30 is root 3 by 2. Once we have this value, you will find the value of v2 coming out to be 20 meter per second, because J only has a component in the final part and the initial part only has a component in the initial or the I direction. So we cannot calculate or put in the x direction to the y direction. So use the x directions for both the sides to be equal, and we find out the velocity. Thank you.